Hi everyone. Uh, I am Ashish Das. I'm an IT solution architect. I'm passionate about solving real world business problem with technology. Okay, so in one of my previous webinar, we basically touched upon a little bit about containerization, Kubernetes, etc. However, I thought that today we'll cover a bit of lighter topics. Which is basically an overview of cloud, why cloud, what is the need for that, a bit of history about that, and a bit of very high level overview of GCP, like Google Cloud Platform core infrastructure and core services. Yeah, so in next 30 minutes, 30 to 40 minutes, whatever we're gonna discuss, so based on that, you will be able to get an a rough idea of what all cloud services you can opt for your websites or your applications, and how what are the components you need to consider while designing a cloud migration from on-premise to say Google Cloud. Yeah, so there is a case study. It's basically in our hometown, there was a travel agency known as Ram Babu Travel Agency. So during COVID time, I mean, what happened is everybody were out of business, and so does Ram Babu Travel as well. Uh, okay, they tried hard. They had on-premise application earlier, and during COVID, obviously, because it was locally deployed, so they were not able to cater the customers on multiple region. And also the major problem was once the people were kind of accustomed to COVID and they started their normal life, so there was a very huge load into their websites which they could not pick up. Okay, so at that time, say they thought that okay, they will uh, solve or they'll reimagine their business. They just want to go from local to global, and a lot of the customers they were serving at that time, they were being traveled from India to Dubai to UK to USA to Canada. Yeah, so they thought, why not, catering those same services, the same customers, but from multiple location. Yeah, so they come up with this idea, and then they obviously give set of requirements. Obviously, they had given main features like travelers can search and book travel, and also obviously at the same time they can search hotels, flights, trains, or yeah, even cabs as well. And they want to extend this platform to the third party as well. If anyone, let's suppose a taxi agency, they also can come and register with these guys, and then they can collaborate. And the pricing will be individualized based on the customer preference and the demand as well. And they want to integrate with uh, social media, and they want to capture the review post and obviously run a lot of analytics based on the user ratings and other parameters. Similarly, the inventory for different suppliers while booking a ticket for say, they just want to integrate with the different third-party suppliers inventory on the real-time basis. For an example, on airlines. Okay, so the ticket or the number of tickets, what how it is exactly in the back end of the airline, so that it has to be visible on their website as well. So they have listed a few typical users, such as your customer, traveler, manager, inventory supplier, and so forth and so on. Yeah, this is high level. They gave the requirement, and uh, they were kind of discussing how they can solve this kind of problems. So yeah, so while solving this particular business problem, we we thought that okay, so because it is covering entirely a migration from zero to nth in the cloud journey. So basically we thought that okay, we're gonna put all this concept together. So okay, so why cloud computing? So if we generalize this particular thing now, in traditionally, uh, as you know, this Rambabu travel, they face this particular problem. So the peak usage happens only during holidays and weekends, right? So and the other time there are some less load on the applications and yeah. So how to solve this problem? So few things, a few of the customers, they will say, okay, what we will do, we'll buy or rent some infrastructure for only the peak load. Okay, so okay, if you will buy infrastructure during the peak load, so you have a cost now, right? So what will happen during the off peak hours or when the load is less? You still, you have to give, I mean, your cost will be still there for the entire infrastructure. Okay, so now what will happen, for different startup also, sometimes this problem happened, that suddenly they become popular, right? So now how to handle the sudden increase of load? So in the cloud solves this particular problem. So basically what we can do, we can buy, sorry, we can procure or basically provision or rent infrastructure whenever it is necessary, and whenever it is not necessary, we will just release those resources. So uh, so yeah, the cost can be, it's a little bit cheaper in that case. So uh, and obviously during on demand, whenever the load is high, it will be an on demand resource provisioning, and it is also called as elasticity. So there are many advantages. One is we will have uh, less capital expense. We will have, okay, obviously more of a variable expense, and we will get the benefits of economies of scale, because if a cloud provider is has created a lot of resources, so obviously in the wholesale rate you will get that, and that discounts he will gonna pass on to different customers. So definitely the end users will get the economies of uh, scale. Obviously we'll gonna stop guessing capacity. Whatever capacity we just need at during the runtime, we'll get that. And the major advantage, obviously, we can go global in actually in few minutes. So if we're gonna define the cloud computing, basically that is it will have uh, majorly five criterias what the Google has defined. Firstly, the first criteria is customer must get compute resources that are on demand and self-service. Okay, so through a web interface, user can get the processing power, storage, network, and whatever actually they need for without human intervention. Okay, so it should be automatic. And obviously they should be able to get the access to these resources from anywhere within just an internet connection in a secured manner. Okay, this is also a very important characteristics. And the third one is the cloud provider has a big pool of these resources and allocate them to user from those pools. So so basically it's you can see it's a kind of a pool of resources. Whenever it is necessary, few will be allocated and the rest it will again go back. Whenever not it is not needed, the resources can be released and it will go back and sit in the pool again. Yeah, and the final point, it has to customer will pay when they use. Uh, uh, yeah, and or when they were use or whenever they will reserve, and otherwise they will not pay anything. Okay, obviously there are different models out of those, but yeah, basically whatever they will use or whatever they will reserve, they will gonna pay only that. So this is what These are the characteristics of cloud computing. Okay, so what we're gonna do, we're gonna discuss about few examples of our services in the Google Cloud platform. I'll just so the cloud console, and then we'll try creating a few services like compute engine or virtual private network, etc. Yeah, so okay, so this slide I just put as an to narrate the history. Obviously, this the reference of this again in the Google Docs. So the first wave of cloud computing, it happens during the age of colocation, where we discussed about whenever early in the earlier case, few of the companies, they were buying or procure infrastructure in a shared in a shared environment, or they call as co-location. That was quite popular. Then the second wave happened. So basically, wave provider, they will provide their virtualized data center. So yeah, this is the same kind of concept as first wave. However, it is more in a virtualized manner. But now the third wave, what Google is saying is, okay, so in this third wave, we'll have a container based architecture. So it will have more capacity, to uh, uh, more elastic in nature, and more automate as well. uh, yeah, so this is what the evolution is. Okay, why Google is towards this container based architecture and on this cloud? uh, yeah, this because uh, what Google believes that in the future, every company, regardless of the size or the industry, will differentiate itself from its competitors through technology, right? So increasingly, this technology will be in the form of software. So how a very good software runs with, I mean, a very good software will run with uh, good quality data, right? So eventually, each and every company will become a data company. So now, uh, because we generally listen this cliched statement that data is the new oil, right? So we need very effective solution to manage this data on a real time basis in a secured manner. Okay, because the more we are now trying to a distributed architecture, the more risk also is there for the data is being leaked by different hackers, etc., right? So at that time, uh, different security measure also cloud providers are providing, and security is something that both the cloud providers and the end companies, or whoever using these cloud services, it's a shared responsibility. Few of the security features actually being provided by cloud providers, and obviously and the others are obviously it's responsible by whoever is using it. Obviously, we'll cover more about the security and other features in the late subsequent sessions. Yeah, so now coming to different cloud basic terminologies. Okay, so uh, in a day-to-day conversations, maybe you would have listened to different these terminologies such as infrastructure as a service, platform as a service, container as a service, function as a service. So what do we mean when we say infrastructure as a service, or on these terminologies? Yeah. Okay. So what is a when you say infrastructure as a service? So we want to continue running application on the cloud in the same way how we run in the data center, right? So now in this example of Ram Babu's travel application, so there are multiple ways that those requirements can be achieved. The first one is obviously we will the company will gonna write the code as a in-house. They will gonna host it somewhere, and they will gonna manage the OS. They will gonna manage the auto scaling, OS upgrades, availability, etc., etc. So that is known as infrastructure as a service. So basically, uh, the cloud provider. Okay, so there are different components in a software application. For an example, we have networking, physical hardware, virtualization, operating system, application runtime, and finally the application and the code. Right. So for infrastructure as a service, if someone is opting for that, then cloud provider is responsible for physical hardware, networking, and virtualization. These three things cloud provider will be responsible. However, whoever is taking the service, infrastructure as a service, it is their responsibility for application code and runtime, configuring the load balancing, uh, also the auto scaling, OS upgrades, patches, availability, all these things. It is responsibility of the person or the company who is taking that service. Similarly, platform as a service is just again one step above infrastructure as a service. So when you say platform as a service, the cloud providers is basically responsible for even for OS, including the upgrade and patches, their application runtime, auto scaling, availability, load balancing, etc. There are multiple version of platform as a service. Sometimes the container as a service uh, also that is being provided. Function as a service also that is also provided functions instead of entire application. Uh, so the Google Kubernetes engine, that is an example of container as a service. Similar, Google App Engine is a platform as a service example. Google Cloud Run, that is again a container as a service. So there are different similar cloud function is something where you don't. It is a kind of completely serverless function. So where you are not worried about your the servers or the management of that, the auto scaling, etc. You will just write your code inside the functions. The uh, cloud provider will take care all other stuffs. Okay, so your yeah. So some serverless. This is a very buzzword these days. So sometimes people misunderstand that. Okay, serverless means there is no server, but that is not the case. Serverless means your cloud provider is taking the full responsibility of the server, all the management of the server. We just have to uh, worry about the application code, etc. Yeah. Next one is regions and zones. Uh, okay, so I'll try to draw something. Just a sec. It's not working for some reason. Okay, anyway. Okay, so what is regions and zone? Imagine an application is deployed in a data center of London. Okay, so now what are the challenges? The challenges are it is slow access from the other parts of the world, right? Similarly, uh, what if the data center crashes? So the application will definitely goes down. So basically, it is also low availability. One of the
See,
problem is low availability.
hello,
So now,
Ashish.
yeah.
Your screen is not visible. All we can see is Google Cloud basic terminologies. I think you're drawing something.
Just a sec. Um, s- Okay, so sorry about that. It was an kind of technical glitch. Okay, so what we are discussing, regions and zones. Okay, so for an example, let's suppose we have a region called London. No, it is not coming well. Anyway, I'll just explain. We need a better setup for this. Yeah, you can see the screen now.
Yeah, I can see the Google Cloud basic terminologies. The
Yeah,
Miro screen actually went out. So
it's
where you
actually not responding properly.
okay, no problem.
So yeah, so basically we need a better setup for the next time.
Yep, no problem. That's fine.
Yeah, okay. So if we add a more okay, we are discussing regions and zone. So imagine that our application is deployed in a data center in London. So what will happen while we are accessing the application from other parts of the world? It will be that we will feel some slowness. So this is because of the high latency, right? So there's a second challenge. Challenge is, what if the data center crashes? The application will definitely go down. So that is low availability. Okay. So what if we have multiple data center? So if you have one more data center in London itself, so now the slow access of the user is still be there because it is far away. But the problem number two, that was what if the data center crashes? We still have another, I mean, availability for by another data center, right? So what if the entire region of London is not available? Then the entire application will goes down. So this
Ashish,
is where,
would you like
yeah,
to show an image from Google Images? Just I typed regions and zones in GCP, and there are certain images. If you want to use them and showcase, there are maps and all that. No, you can directly go to images. Go back. Yeah, click on the
yeah.
images. Yeah. There.
Which one you're talking? This one?
Yeah, the first map, if you want to explain the latency, the scalability, you can talk about the second image like that. You can just see if this can be useful.
Yeah. Anyway, okay. So we are discussing about regions and zone. Okay.
Yeah, you can
So
download that picture and then explain, I think.
ah, nothing is visible. Let me directly show here if it is there. Yeah, okay. So in an Google Cloud environment, while creating each and every resource, we'll have to specify it to which region and which zone we need to deploy this. Okay, it can be it can be of multi multiple region. It can be of again multiple zone. Okay, so one region is being divided into multiple zones. For an example, the region is nothing but a one geographical area. So here inside US, it has North America, Northeast one, something something, even US Central one. Okay, so let's select US Central one. So US Central, under this US Central one region, we have multiple zone such as US Central C, A, F, B. So this is nothing but one region is again divided into multiple zones, so that if one region, one zone is the application is going down, so another zone will provide the backup for that. And similarly, what if the entire region goes fail? Then if our application is deployed in multiple region, so for an example, it is deployed in US Central one, and it is also deployed in Asia Pacific. This, let's suppose Asia South Mumbai. Okay, so then if even if our US Central one is down, then this Asia South one, this particular infrastructure will be up. So a high availability is still maintained. Okay, so this is regions and zones. We're gonna move back to other. Yeah, next is compute engine. Okay, so what is a compute engine? In your data center, while we are deploying any code or word, we are deploying into a physical server, right? So now, how about in a virtualized environment? So in a virtualized environment also, sometimes we do create virtual servers and then we deploy uh, our codes and services into that. So Google compute engine is nothing but it provides the entire options to create VM instances and the management of that. So how to create that? If you go to Google Cloud, so this is the Google Cloud console. Um I mean, anyone can actually get a free license of Google Cloud Console. You just need an active credit card for that. If you have a Google account, your Gmail account, you just type console.cloud.google.com. Okay, and then it will ask for certain billing information. For an example, uh, here, yeah, it will ask certain billing information as your credit card details, etc. It will not charge anything. It will give $300 for 90 days. Okay, and whatever resources we're gonna create here, it will be from this trial account of 90 days and $300. Uh, and once the 90 days is over, then all the resources, whatever we have created in this Google Cloud Console, it will gonna be stopped, and Google will send you a notification. If you want to utilize these, please upgrade your account, and that at that time, there will be bill on the credit card. Okay, so we don't have to worry till the time we are just creating our resources from the trial account, and once our purpose or learning purpose is completed, we are just deleting those resources. Yeah, this is how we're gonna set up. And once you are uh, typing this cloud.google.com, you're gonna land up in this particular page. That is a dashboard page. I'll show you that. Yeah, this is the dashboard page. Because how the resources are there in the Google Cloud, we have a specific resource hierarchy. Okay, so we have every resource, it has to be part of a project. Okay, so here it is a default project. So under, whenever I want to create a virtual machine or a compute instance, so it has there should be a project. So this is a default project. If I want to create a new project, I can also create a new project. Okay, so here let's suppose I'm just uh, a D project. I'm just giving some random name. create. This name is invalid. Enter latest numbers, single quotes, hyphen, spaces. Okay, this is not allowed. Yeah, the project is created. It will take a few minutes. Yeah, the project is created. So now I can go here and select my project. So now I'm in AAD project. Now I'll go and create a compute engine. So under compute engine, we'll have VM instances, instance template, sole tenant, machine type, TPU, a lot of things. Okay, so let's create some VM instances. So basically this is virtual machine instances. Yeah. First, we need to enable the compute engine API. So how we can interact with Google Cloud Console is okay on this graphic GUI, graphical user interface, and also we can interact via gcloud commands on this cloud shell, and also we can interact via app. There is an app already Google has provided. So via that app we can interact, we can manage, create the compute instances. Yeah, it will just take few seconds. Okay, while it is getting enabled, let's discuss about the other terminologies what we put there in our slide. And then later we'll come back. Yeah, so we have discussed compute engine. Okay, we're gonna discuss the demo. Cloud VPN and VPC. Okay, so what is the cloud in a layman term? What is a VPN and what is a VPC? Okay, so sometimes I have seen few of my colleagues also they get confused between these terms, these two terms. Uh, okay, so if I tell a story, basically a layman story. Uh, okay, sometimes what happen is we have seen in certain Hollywood movies. Uh, this is a, let's suppose this is a road, and this is a somebody is some sort of thief is going in this direction, and someone and the police or FBI agent, they are just, I know my drawings are not good, but yeah, so they are in the helicopter, they are tracking, and suddenly this guy on the bike, he will go into a mountain in a tunnel. Okay, so now this guy, this helicopter will not have any idea about till the time this thief is there inside this mountain, these guys will not be able to track it. Okay, so similar sort of things happen inside the internet also. So we want our data, our resources to be completely isolated from the outside environment, and then uh, so that nobody will be able to track it. So that is where that is called as virtual private network. So basically we're gonna create an environment uh, that will be completely secured. And what is VPC? VPC is virtual private cloud. So inside the Google Cloud environment, we have, we have the capability to create our resources that will be completely isolated, again, with other GCP infrastructure or other GCP resources, and how we're gonna so the resources inside that VPC can communicate with each other. Okay, and what is Cloud VPN? Cloud VPN is something that will gonna help you connect from an on-premise to your public cloud. Okay, so how it happens? It happens through a tunnel. It's they create certain IPsec tunnel, and that is how they connect from an on-premise network to your public cloud or public internet. Okay, so the next is firewall rules. Firewall rules, so these are nothing but different, basically different rules. Those have been created while connecting in a uh, uh, in a VPN, in a network or in a subnet, etc. What is a load balancer? Load balancer distribute the user traffic across instances of an application in a single region or multiple region. Yeah, so there are multiple types of load balancer. So uh, basically the load balancer, it enables high availability, auto scaling, resiliency. Yeah, there are different type of load balancer. One is as you one is HTTPS load balancer, TCP load balancer. Uh, so what happens is we know there are 7 OSI layers are there, right? So the um, uh, different layers are there: network layer, transport layer, application layer. So in the application layer, the protocol that is used, that is called as HTTPS protocol. Okay, and this is more secure. Similarly, for the different REST API calls or send emails, it happens in the application layer. Okay, for in the network layer, there are it is less secure, but it is performance wise, it is a bit higher. Okay, so it transfer bits and bytes at network layer. Similarly, at transport layers, they are also bits and bytes are transferred. Okay, so we will cover more about the load balancing as we go along in the webinar. Okay, I think our compute instance API is enabled now. Okay, to create an compute instance, we can click on create. We have multiple options. New VM instance, new VM instance from a template. So basically, while whenever we'll create a new VM instance, we'll have to fill all this information. There are a lot of information to be filled. So instead of that, what we'll do is we'll just create a template, and whenever it's actually required, so we will just tell, okay, we need from this instance template, we need 40 instance to be created. So at that time, entire 40 VM instance will be created from one single template. So it's basically more management wide. It is better. Similarly, we can create VM instances from a machine image. So what it is? So basically, we can create single VM instance from an existing machine image. So once I create this image, this instance, I can take a snapshot, or I can save that somewhere in the disk and as an image, and I can use that image in in a different form. So while creating a VM instance. Similarly, one more option is marketplace. So in the Google marketplace, there are ready to go solutions available. So we can just get that, and obviously there will be certain uh, deployment as a service. There will be certain Terraform codes. We'll have to just run that, and in the background automatically everything will gonna be created. Okay, anyway, for this webinar, we'll just stick to new VM instances. This one manual, we need to give a name. Let's suppose AAD instance 1. We can add levels. Levels are nothing but to uh, identify this particular VM instance. So let's suppose in an organization we have dev environment, UAT environment, prod environment. Okay, so we, or even if in the dev there are applications for customer, for billing, for reporting, etc. So So we have to add any, we can add any levels, and based on that we can filter later. Okay. So as of now, I'll refrain. Okay. Anyway, name must be considered lowercase, all lowercase. Okay. Yeah, region we discussed already. So let's suppose we'll take US Central 1 with Zone US Central A. Machine configuration here again, this is a very important step. So based on this, the prices will be differ. So for the general purpose, let's suppose I'm creating E2 series and machine type is E2 medium 2 CPU 4 GB. If you want to change, so I have there are N2, N2D, T2A. For different computing power, there are different machine types are uh, given here. So I can select. Let's suppose I want to select N2 and I want to select N2 standard 8. So now my costs will gonna go up. So here the monthly estimate is $227. The item is 8 virtual CPU plus 32 GB memory. Yeah, and what we are getting 10 GB balanced persistent disk. We can again change this to SSD if we want SSD. Yeah, that also we can add here. Similarly, we have compute optimized series also there, C2, C2D. We have memory optimized things, which is powered by Intel Skylake CPU platform, etc. Similarly, if you want GPU, we have the option of GPU, NVIDIA T4, etc. Okay, so as of now, for the learning purpose, we'll keep to default option, that is E2. Okay, similarly, we can add here, if anything, we want to add CPU platform. Okay, I think this is only for the other machine types, not for this E2 one. Okay, so confidential VM service. This is again, this wasn't one of the new thing which is added recently, which is confidential computing. We can enable it. What is this? Basically, if you want our data, which will be there in this particular virtual machine, to be encrypted, and Google will also have not any access to that, then if you want that, then we can enable this. As of now, I'll refrain enabling that. Again, containers. Okay, if you want uh, container image, hard container OS image to be deployed, then we can go through this. But anyway, I'll refrain from that now. Yeah, this is the boot disk. We can change if you want. So the here I can choose operating system. So it is Debian, Fedora, OpenUC, Red Hat, whatever. Even Windows also I can add. Yeah, so I can even add custom images, snapshot, archive snapshot, existing disk, depending whatever is my requirement as of with respect to that, we can uh, select this. Even the version for Debian, there are 3 version 10, Debian GNU Linux 10, uh, GNU Linux 11 Bullseye. Okay, so I'll select that. Boot disk type, we have, as I was mentioning, persistent disk, extreme persistent disk, SSD disk. Yeah, so these are certain advanced option. I'll just keep balance persistent disk. Size is 10 GB. I can, let's suppose, change it to 20 GB. There are certain again advanced configuration. Snapshot schedule if you want, yeah, encryption key. Okay, so this is a pretty important concept. Okay, encryption keys. Uh, okay, so by default, all the data at rest in Google, those are already encrypted. However, what about the data which are at transit? So whatever the data sometimes transit in the internet as well, right? So at that time, there are multiple encryption technique being used by Google. One is Google managed encryption key, customer managed encryption key, and customer supplied encryption key. So yeah, all 3 different things. Okay, as of now, we'll select Google managed encryption key. Uh, yeah, that's it. We're gonna select this one. Then identity and API access. Here default, okay, service account. So what is a service account? Service account is, okay, any resource in the cloud, it has to be accessed by human or non-human. When I say human, so and some person or some user will gonna access it. And when I say non-human, so another service of or another process or another web service, it will gonna access it. Okay, so how we'll gonna manage that? So either we can give our own credential in the code itself while accessing that, but that is not a good idea. So that is where the service account concept of service account comes into picture. So here the service, giving a service account, creating a service account means it will just give the required roles and permissions to that service account to create, let's suppose, this is a default service account that Google has automatically created for every resource. It is managed by Google as well. There will be no password. There will be a token based authentication between the service account and the corresponding resource. Yeah. We can also create our own service account, and if you don't want this default service account to be here, so once we create the service account, it will, those will be appeared here, so we can select that service account. As of now, I'll stick with the default. Access of options. So default access, allow full access to all cloud API. Yeah, so uh, okay, I'll just stick to default access. This is the firewall what I was talking about. So by default, basically, this is the rule for the ingress and egress or incoming or outgoing traffics. Okay, so as of now, I'll put allow HTTP traffic. There are other advanced option also, which are related to networking, disk security, management. So okay, networking, so that we already discussed. Uh, that the virtual private network, if you want, by default this will be part of Google created a default private virtual private VPC. But if you want, if your requirement is there, then we can create our own VPC and we can tag that. There are network tags also. Network tags are nothing but certain types of firewall rules that only these things will be allowed here. Yeah, so as we can define, as of now, I'll for this particular webinar, I'll just refrain entering anything. I'll just yeah, this is the default uh, VPC, default network and default subnet. Yeah, we'll cover more about VPC in a detailed session. What are network, subnetwork, CIDR blocks, these blocks, yeah. IPv4 alias IP. This is the external IPv4 is ephemeral. Yeah, I'll just create. Make sure all fields are correct to continue. Go to issues. Where is the issues? Okay, I haven't clicked yet. Done here. On host terminals, recommended. Yeah, it will gonna create some time. Yeah, it will take couple of minutes. In the meanwhile, we're gonna discuss the other things, and we'll again come back. Okay, so next one is cloud identity and access management that we briefly touched upon. So we have your cloud provider. They have to, manage Google Cloud has an this particular service is cloud identity and access management. Basically, it is authenticating the right user and authorizing the right access and to a specific user. So there is a possibility for granular control as well. So uh, basically we want to limit a single user to perform a singular action on a specific cloud resources and from a specific IP address. And also we can control the specific time window as well. So all this granular controlled services can be uh, those are provided by Google Cloud. Service account we already discussed. Cloud SQL. So this is okay. There are different database services which are extensively we will have to if you want to cover in a later slides or later subsequent series. So as a basic, so this is basically a transactional database or OLTP, I guess. Yeah. Uh, yeah, so all the structure. So earlier we were using that MySQL database. So that is what in the Cloud SQL. So they have also options on PostgreSQL. Google Cloud SQL it is specific to one single region. Uh, if you want to create on multiple region, that also can be possible. However, Cloud Spanner, it is by default, it is on multi-region. So it is also again for transactional processing on the structured data. However, Spanner is more of a, it is by default, we have to give multiple region on that. Yeah, NoSQL, okay, Google also provide uh, uh, services for unstructured data. So there are a lot of NoSQL database in the market, but Google, I think, it provide Firestore as a NoSQL database. It also has Cloud Bigtable. It is a very wide column database for time series data or data which are coming from different other platform on a continuous basis. Yeah. Also, there are in a data analytics solution, there are BigQueries, there are data lake. Yeah, so those things I haven't included here because it's pretty basic webinar. Similarly, for deployment services, we have Google Cloud Deployment Manager. So once the code has been developed, even these resources, even infrastructure as a service, these resources, those can be automatically with a single script. It can be deployed, or it can be created or deleted. So, there are different tools available inside Google Cloud. So one is the Google Cloud Deployment Manager really helps on that. We also have the capability of Terraform. So it's basically if you want to, I mean, create a script. Okay, we want this machine type, this thing, uh, specification. Oh, create this much of uh, virtual machines or instance group or even other resources as well. Cloud logging and monitoring. This is while for operation. So sometimes what happens is it is necessary to monitor different applications to undergo to analyze their load when is the peak load, when is the uh, less load, or if whether we have any what is the latency, etc. There are a number of parameters we want to know. So for those purposes, we have these tools, cloud monitoring tool. Similarly, cloud logging tool is for getting the logs. There are again multiple tools such as cloud profiler, cloud debugger, error handling. So all these things are also there. Yeah. So I think as we speak today, there are 400 plus services available inside Google Cloud. Uh, yeah, so the idea is just to know basic services, and as in whenever we need anything, we can definitely explore further. We'll see our virtual machine is ready. This is up and running. This is the internal IP, and this is the external IP. This has been assigned, and this is ephemeral. Ephemeral in the sense that every time I'll gonna stop this virtual instance, this and the start again, this IP will gonna be changed. However, we have options to make this static. Okay, so by default, Google's external IPs are ephemeral. This is SSH. If you want to connect to this, we can connect to this through SSH. Anyway, it will gonna take some time. Anyway, we'll just cover the things. Yeah. So whatever we discussed, this is the sample. I mean example. Uh, Different IaaS, container as a service or platform as a service or function as a service. So Google Compute Engine, it provides high performance and general purpose virtual machines that scale globally. Okay, it's a category comes under IaaS. Similarly, Google Kubernetes Engine, it is an orchestrated containerized microservices on Kubernetes, need an advanced cluster configuration and monitoring. It is categorized as container as a service. Similarly, App Engine. App Engine is nothing but we if we have an application, we can directly put in their platform. So basically, it's build highly scalable application on a fully managed platform using open and familiar language and tools. Obviously, there are different types of App Engine. App Engine Standard, App Engine Advanced is also there. So okay, these are platform as a service. Then cloud functions that we already discussed about. So say event-driven application using simple uh, functions. Cloud run is also there. Again, this is an container as a service. It's basically develop and deploy highly scalable containerized application. It does not need a cluster. Okay, this Kubernetes here we need a difference between GKE and this cloud run is here we need a cluster. Here we don't need a cluster. In a multi-cloud environment, also there are other services such as Anthos and other. I'm not able to recollect that. Yeah, but we can always go back and check. Yeah. So these are the services of Google Cloud, basic services of Google Cloud. So what we discussed in our sample travel application. So this is how the design will go through. So we will have an web UI, we will have an mobile UI. It both will go through an authenticated service. Okay, so once it is authenticated, so then this web UI will have the both will be connected to this particular block where search service and order service will be there, and both this will be connected under a transactional database. We can use Cloud SQL, we can use Cloud Spanner, depending on okay if you want to go global, so we have to use Cloud Spanner. So again, we have an inventory service. So uh, again, for inventory service, there will be a separate database. For analytical service, we have a data warehouse. For reporting service, we can utilize BigQuery or Looker or other solutions. Yeah, so this is the very basic step of designing this our travel application. Now the next step is obviously we want to create what a load balancing will be required. So here, this is since this is in third-party authentication service, and it has to be connected from mobile app or from web UI. That it will be an HTTP because it's connected to end users. It will be HTTPS load balancer, so our global HTTP load balancer, and all this different search service, web UI, inventory. So this is part of one VPC, we can say. So so here we don't need HTTPS, we need TCP. We need TCP load balancer. Okay, so forth and so on. So here, why this one we put it as an outer block. So here, this reporting service, it is basically there in our corporate network, and we can connect through this analytic service through VPN. Yeah. Next one is with respect to the failover. We have added the failover here. So basically, we have added two zones, sorry, two regions with two zones. One is US Central one and Europe. And here again, it's if you are using a spanner, automatically there will be a failover. Or if you are using Cloud SQL, so it can be extended to multiple under your central one region, your central A and your central B. We can use your central B as a failover. Yeah, so this is how the simple design will go for a travel application. Yeah, there are other components as well. There are security, there are service accounts which need to be added. There are monitoring services, logging services, profiler, cloud armor. So other things are also to be taken care. However, I believe this will provide a good starting point to visualize this. Yeah, this is what I want to cover for this webinar. We're gonna see with the Kubernetes and its architecture and deployment on Google Cloud Platform in the subsequent session. If you have any question or any doubt, you can always contact us to contact at imesh.ai. Thank you.
Okay, that was pretty long.